Okay then, so this is our digital line demonstration, and what we're showing here is how a machine builder or OEM could virtually commission their production line on individual cells to prove and validate their process of engineering upfront as best as possible. So what we've got here is 5 separate simulations of 5 different cells, and what we're actually producing here virtually, at least, is one of our S7 1500 PLCs. So you can see here from the left to the right hand side, we go through the placement of the machine, mounting, pressing, so pressing the casing together. We've then got the labeling, and then again the packaging right at the end. So there's a number of different components here, and each of these cells is doing its own thing. And this is not necessarily just an animation, this is actually a real physics and electrical simulation. So this is really driven by the underlying PLC code, so that is the program that would really run this in the real world. We have what we call PLCSIM Advanced, so this simulates our PLC, so that's our S7 1500, and that simulates the tags, the variables, and everything from the automation program that then comes through to what would be the real machine itself. From that side, we've then got a package called SIMIT, and SIMIT simulates the electrical component behavior of things like drives, RFIDs, any inputs and outputs that are coming from the real machine. And in this case, that is a software in loop simulation. And what we mean by software in loop is that we've then got NX MCD, so that's NX, a CAD package with Mechatronics Concept Designer, which really adds in the physics and kinematic elements into this model. So you can see here we've got both the model being driven, so from a conveyor, from a robot arm here, to then the welding and pressing components. And each of these parts is then driven and then fed back into the simulation. So that's things like light gates, booleans that are then flipped and then put back into the automation program. The benefit of this for a machine builder or end user is that they can validate and engineer upfront as much of their process as possible. Any mistakes that are made in the simulation are far, far cheaper and far, far quicker to rectify than in the real production or real machine. Other benefits of this as well are things like operator training. So you can see here on the top side we've got what is called WinCC Unified. WinCC Unified is our visualization and HMI software. This is browser based, but this is where you'd be able to generate and engineer your virtualization and visualization of your HMI screens. In this case, you can then train an operator, for example, for each of these stations, how that would work and what alarms or faults to look for example, in that machine when it's actually running. Between each of these, we have a virtual Ethernet adapter, which means that station 2 talks to station 3, which talks to station 4, and each of that is simulated and synchronized by the virtual PLC on the back end of this. Lots of benefits of this come for a machine builder in terms of integrating one machine into a line, making sure it talks to its peripheral components, but also that engineering up front that can speed its time to market, reduce errors, and also improve quality. The final part of this is once we have the digital twin, and then this is in production, we can then run scenarios. So for example, what happens if we speed up the conveyor? Does that make our production increase by 10%, or does it actually create a bottleneck during the end? So all these scenarios can then be run, which then feeds back into the process and can improve that quality, improve that product. And for us at Siemens, that's what we call virtual commission.